Irodov problem number 1.63. The following parameters of the arrangement of figure 1.11 are available. The angle alpha which the inclined plane forms with the horizontal and the coefficient of friction K between the body M1 and the inclined plane. The masses of the pulley and the threads as well as the friction in the pulley are negligible. Assuming both bodies to be motionless at the initial moment, find the mass ratio M2 by M1 at which the body M2 A starts coming down, B starts going up, C is at rest. Okay, let's draw the diagram first. So the first step in these problems is to draw the free body diagram. So for the system M1, we have M1G acting downward. If this is the plane, there is a normal reaction, okay, and there is a tension force on the string, okay. Now question number A says M2 is going down, so M1 is going up. If the relative motion is this way, friction force will be this way, okay. As for M2, M2G tension, okay. One other thing that I like to do is I like to denote the direction in which acceleration is happening. Let's say the acceleration is A. Because this is the same string, continuous string, the acceleration will be same for both M1 and M2, okay. So this is question number A. So for this, we can therefore write the equations of motion. So T minus F friction minus, now this angle is alpha. So M1G's component along the surface of the plane is M1G sine alpha will be equal to M1's acceleration, Newton's second law, and from here we can write M2G minus T is responsible for this acceleration M2A. Further, because this is kinetic friction, we can write F equals Kn. N is equal to N is equal to M1G cos alpha. So this is M1G cos alpha. So let this be equation 1, this is equation 2. From 2 we can find out the tension and substitute here. So that becomes M2G minus M2A, this is tension force, minus K M1G cos alpha is the friction force, minus M1G sine alpha equals M1A. Now let's bring the A terms to one side. So this becomes M1A plus M2A, bringing that side, and remaining M2G minus K M1G cos alpha minus M1G sine alpha. Now when M2 just starts coming down, A is greater than equal to 0. In the limiting case, A is equals to 0. So we can say this is equal to 0. So that means M2G is equal to M1 Kg cos alpha plus G sine alpha, or m2 by m1. G also we can cancel, will be k cos alpha plus sin alpha. Or more accurate would have been to write m2g is greater than equal to, or m2 by m1 is greater than equal to this. Okay. So that's part A. Now, for part B, let's do the free body diagram one more time. There will be a little difference. So now m2 is going up. So m2g downward, tension upward, but acceleration is upward. Okay. Here we have m1g downward. This is the surface, normal reaction this way, tension this way, but now because m1 is moving along this side, friction direction will change, friction will be this side. Okay. So if I write the equations of motion, okay, one more thing I should do is acceleration I have to show is this side. So now we can write m1g sin alpha minus tension minus friction is equals to m1a. And from here we can write T minus m2g is m2a. If I say this is equation 1, this is equation 2. From equation 2, if I substitute value of tension here, so we get m1g sin alpha minus T, so minus m2a minus m2g minus friction, the magnitude of friction remains the same, k m1g cos alpha is equal to m1a. Now let's bring all the m1a terms, the a terms to one side, m1a plus m2a is equal to, we are left with m1g sin alpha minus m2g minus k m1g cos alpha. Now when m2 just starts going up, a is greater than equal to 0. So this will be greater than equal to 0. Now m2g, if I take it that side, will be less than equal to m1g sin alpha minus k m1g cos alpha. G we can cancel. So m2, and let's take m1 common and bring it that side, will be equals to less than equal to sin alpha minus k cos alpha. And number C, case C, is when both the bodies are at rest. For case C, it's a case of static friction. And one key thing about static friction is it's a self-adjusting friction. So I cannot say friction is equals k m1g cos alpha. Okay. So let's look at m2 by m1 values. So m2 by m1, if it is greater than k cos alpha plus sin alpha, then m2 falls down. And if it is less than sin alpha minus k cos alpha, if it is greater than, then m2 goes down. If it is less than this, then m1 goes down. So when m2 by m1 is in between, so m2 by m1 is greater than sine alpha minus k cos alpha and less than k cos alpha plus sine alpha, then both m1 and m2 remains at rest. Alright, so that's our solution.